In the deep and ancient dark between the stars, where motion itself is a form of silence, a single point of light moved through the cosmic dusk. It was faint, no brighter than a smudge on the sensors of an automated sky survey, but it carried the weight of distance, a messenger from somewhere beyond the sun's dominion. The astronomers who first saw it gave it a name drawn from the machines that found it: 3I Atlas, the third interstellar object ever observed passing through the solar system. To most it was a rock, to a few it was an omen. The telescopes that tracked the sky every night, those tireless eyes that never blink, caught its slow arc against the background stars in early 2024. Its orbit was wrong, hyperbolic, precise, too fast to belong. That curve, traced in equations, was a signature of exile. 3I Atlas was not born here. It had crossed the great gulfs between suns, carrying the chemical scars of another system's birth. The discovery was exhilarating but familiar. We had seen this story before. In 2017, an object named Oumuamua entered from the same void and left behind more questions than dust. It, too, had moved strangely too fast, too light, too silent. But time and limited observation had erased certainty. Scientists promised they would be ready next time. Now, that next time had come, but readiness meant little in the face of what followed. At first, 3I Atlas behaved as expected. Its faint greenish hue hinted at volatile ices buried beneath a dusty crust, the same chemistry found in comets that drift for eons in the outer dark. Its spin was stable, its light curve predictable. But within weeks, a subtle inconsistency began to whisper through the data. The object's position did not match the model. It was moving too deliberately, as though correcting itself. Its velocity fluctuated in a way that could not be explained by outgassing or by solar wind. Small, precise shifts, not the chaotic flutter of a comet venting gas, but something measured, almost cautious. Around the world, observatories synchronized their clocks and compared their readings. From Mauna Loa to Cerro Paternal, from the Japanese Subaru telescope to the newly commissioned Vera Rubin Observatory in Chile, the verdict was the same. The motion was real. 3I Atlas was adjusting its trajectory with purpose. The question was, why? Some called it instrumentation error. Others invoked natural explanations: jets of vapor, tumbling fragments, unobserved outbursts of dust. But the data refused to bend. Each new observation deepened the anomaly. The thrust pattern was too consistent, the direction of acceleration too precise. Where randomness should have ruled, there was control in the quiet control rooms of night shift astronomers. The usual calm of data processing gave way to uneasy laughter. Not fear, not yet, just the awareness that something had shifted beneath the foundation of understanding. The laws of celestial motion are supposed to be immune to surprise. Every orbit, every fall and return, is written in the language of Gravitia script that has not changed since the first stars ignited. But 3I Atlas seemed to be editing its own path. In archived footage, its light glimmers like a thought moving across a void older than language. Through the noise of the detectors, the faint, green reflection pulses softly like a heartbeat under glass. It is only photons scattered by rock and ice, yet it feels alive. That illusion, the mind's tendency to project awareness onto motion, impossible to ignore when the numbers themselves begin to behave as if they, too, are watching by late spring. NASA's Jet Propulsion Laboratory confirmed what no one wished to declare. Publicly, 3I Atlas's orbit was no longer purely gravitational. The deviation was small millimeters per second of difference, but persistent. Over days, it accumulated into kilometers of unexplained drift. The sun's gravity was pulling it inward, but the object seemed to resist, modulating its descent like a craft navigating invisible tides. It was not accelerating randomly, it was navigating. The idea was absurd. The scientific community had spent years untangling itself from the speculation surrounding Oumuamua, rejecting claims of alien technology as premature and unprovable. But now, those same patterns returned, sharper and closer. Data analysts plotted the variations and found that they formed coherent vectors, consistent with controlled adjustments. The behavior was not just anomalous, it was intentional in its precision. The European Space Agency proposed sending a rapid response probe, a small ion-driven craft that could intercept 3I Atlas before it left the inner solar system. But approval would take years, and Atlas would be gone in months. So the world watched, helpless, as this faint emerald traveler continued its unhurried descent toward the sun. Each observation revealing new hints of design where there should have been none, and yet, the narration of the universe has always been one of humility. Every time humanity claims to understand its story, the cosmos offers a correction. Perhaps 3I Atlas was not an intruder, but a reminder that knowledge, like orbit, is never fixed. That even matter can behave like a question waiting to be answered. In the great stillness of space, there is no sound, only motion. And if motion can imply intention, then 3I Atlas is no longer just a fragment of matter. It is a sentence left unfinished, drifting across the dark, waiting for someone or something to complete it. And somewhere beyond the telescope's reach, the object tilts slightly, as if considering its next move. The night skies turned restless. Across continents, telescopes swiveled in unison, glass and metal trembling under the quiet urgency of something unexplainable. 3I Atlas, no longer just a coordinate in a database, had become the center of the world's attention. From observatories on mountaintops to orbiting eyes above the atmosphere, humanity's instruments fixed upon a visitor that seemed, somehow, to be aware of being watched at first. The data was simple: a faint greenish light moving against the deep stellar field, its brightness waxing and waning like a heartbeat filtered through time. Then came the inconsistencies. The light curve, expected to fluctuate randomly as sunlight scattered off tumbling debris, began to pulse in deliberate intervals. Not perfectly, not evenly, but with enough rhythm to make astronomers uneasy. Every night, the same pattern re-emerged, a dimming and brightening that defied the casual chaos of a comet's spin. The Pan-STARRS array in Hawaii, the Atlas system, and the European Southern Observatory each captured identical readings, despite being thousands of kilometers apart. It wasn't a glitch. It wasn't interference. Something real was flickering out there, something rhythmic, almost musical. Researchers began to wonder whether the object was rotating in a controlled fashion, stabilizing itself with unseen forces. Spectroscopic analysis deepened the confusion. 3I Atlas reflected light in a spectrum no comet should produce. Instead of the typical signs of vaporized ice, carbon monoxide, water, dust, the readings showed a strange metallic sheen, rich in silicates and possibly nickel-ion compounds, more akin to an engineered alloy than frozen rock. Its albedo was too smooth in some wavelengths, too erratic in others, as though parts of its surface were absorbing light, while others were actively redirecting it. No known natural process could explain such optical precision. Some proposed exotic explanations. Perhaps its surface was coated in unusually reflective crystals, or its shape elongated and tumbling created deceptive patterns of light. Others suggested internal heating, even electrical discharges. Though such phenomena had never been seen in an object so far from the sun, But beyond each theory lingered the same unease. The data carried structure. In a quiet conference call between observatories, an analyst from the European Space Agency pointed out something striking. When plotted over time, the brightness fluctuations formed harmonic ratios, simple numerical relationships repeating across hours and days. 3 pulses, then 5, then 3 again. A beat that should have been meaningless began to look intentional. At NASA's Jet Propulsion Laboratory, computers modeled the variations and found a peculiar symmetry between light and motion. Every time 3I Atlas brightened, its velocity relative to the Sun shifted ever so slightly. The changes were small fractions of a meter per second, but consistent. It was as if the object's spin and trajectory were linked by an internal logic, each adjustment compensating for gravitational drift. That discovery sent ripples through the scientific world. Nothing natural corrects itself with such precision. A comet vents gas and dust chaotically, creating unpredictable thrust. An asteroid follows gravity's pull and nothing more. But 3I Atlas seemed to measure its motion, to maintain a path, not by accident, but by awareness. Observatories on opposite hemispheres began a global coordination effort, pooling data across wavelengths from infrared to ultraviolet to catch any pattern humanity might be missing. The James Webb Space Telescope, though never designed for tracking fast-moving interstellar bodies, managed to capture faint thermal readings. It found no obvious signs of heat output, no propulsion, no exhaust. If 3I Atlas was steering itself, it was doing so with a mechanism entirely foreign to current physics. In the silence of night, data analysts stared at light curves on their screens, watching the slow oscillations play out like a cosmic heartbeat. Some tried mapping the rhythm to mathematical constants by prime intervals, hoping to uncover intent where only randomness existed. Others warned against anthropocentrism, against the urge to see signal in noise. Yet, as the hours turned into weeks, coincidence felt less convincing. The question no one wanted to ask began to circulate in whispered emails and private discussions. Could it be communicating? There were precedents, faint echoes of similar mysteries. Oumuamua's anomalous acceleration, unaccounted for by gravity or solar radiation pressure. The untraceable bursts of fast radio signals from deep space, still unexplained years after discovery. 3I Atlas seemed to belong to that lineage of discomfort, data that suggested intelligence without offering proof. At the Breakthrough Listen initiative, radio dishes turned toward its projected path, sweeping across frequencies from megahertz to gigahertz. Nothing answered. No radio burst, no structured modulation. The silence was total. And yet, the light itself continued to pulse, intranslatable, stubbornly regular, maddeningly beautiful. As the data accumulated, the public began to take notice. Leaked charts appeared on forums and social media, stripped of context but rich with speculation. Headlines bloomed across digital front pages. Is 3I Atlas sending a signal? Institutions responded with measured restraint. Press releases emphasized natural explanations, the importance of skepticism. But even official statements could not erase the tension behind the words. The world had seen this pattern before when Oumuamua blurred the line between nature and design, and when the first exoplanets challenged the limits of imagination. Now, in 2024, humanity was staring again into that same abyss of uncertainty. The difference this time was precision. The data was clearer, the readings more stubborn, the rhythms more deliberate. In the control rooms of Chile and Hawaii, scientists watched 3I Atlas glide through the dark like a thought escaping comprehension. The faint green reflection shimmered and dimmed in time with something unseen, perhaps a rotation, perhaps a message, perhaps nothing at all. Each new measurement made the object both more real and more unknowable. A paradox in motion between the graphs and the silence. A realization took root. The universe, vast and ancient, might not be entirely indifferent. Somewhere within its endless arithmetic, intention could exist, not divine, not human, but something shaped by physics we do not yet speak. As the weeks passed, a quiet consensus formed among the world's astronomers. Whatever 3I Atlas was, it was not behaving as a passive traveler. Its light was not just reflection, it was response. And so, the planet watched in wonder and unease, poised at the edge of comprehension. Between the noise of data and the clarity of intent lay a threshold humanity was only beginning to perceive. In the following nights, clouds of speculation gathered faster than data could be verified. Supercomputers stitched together images from disparate observatories, forming composite time-lapse sequences that revealed a subtle choreography. 3I Atlas was not tumbling chaotically, as comets do when sunlight unevenly heats their surfaces. Its motion had rhythm graceful, almost mathematical. Each spin was followed by a pause, each pause by a deliberate shift. Like the hesitation between notes in an unfamiliar symphony, this precision baffled dynamicists. If solar radiation was responsible, it would have produced irregular torque, not symmetry. If internal vents of gas were firing, they would have left traces of volatile emission, yet spectrographs remained silent. The absence of noise became its own kind of evidence, silence, not of emptiness, but of control. Some researchers quietly proposed a radical hypothesis that 3I Atlas might be employing an unknown method of non-propulsive navigation, manipulating the electromagnetic environment of space itself in academic corridors and midnight video calls. Equations met poetry. The idea that an object could steer without thrust seemed impossibly at magnetohydrodynamic interactions. Quantum vacuum fluctuations, even light pressure gradients at interstellar scales began to enter the discussion. Each proposal was met with skepticism, but the tone had changed. It was no longer laughter that met the strange data, but humility. Astronomers at the European Southern Observatory noticed another pattern. Slight alterations in the object's apparent brightness whenever major radio telescopes transmitted toward it. It was not enough to claim reaction, but the correlation was statistically significant. For a few tense days, the scientific community wondered whether the object was responding to electromagnetic exposure rates, dimming and brightening, synchronized not with its orbit, but with human inquiry itself. When the evidence later proved inconclusive, the relief felt almost disappointing. It was as though the universe had flirted with revelation, then turned away. Still, the object's persistence pressed on. Even as it neared the inner solar system, its green hue deepened, not from the sublimation of ices, but from reflective interference patterns, wavelengths overlapping in ways that hinted at structure beneath the surface. Photometric analysis suggested an irregular shape, perhaps elongated like a spindle or flattened like a disc. Though the data refused a definitive answer, every image seemed to contradict the last, as if the object's geometry changed with perspective, or with intent. In the collective memory of science, such moments are rare. They form the fragile boundary between known and unknown, where imagination must tread carefully, yet the implications hung heavy in the air. What if this visitor was not drifting, but observing? What if it had come not by accident, but by design, an artifact to drift between civilizations, carrying with it the residue of its creator's physics, their language of motion and light? For now, those questions remained suspended, unanswered. 3. The first Atlas continued on its silent path, a faint emerald wound threading through the solar winds. Every telescope that watched it was, in its own way, watching itself searching for reflection in the alien. And somewhere between the pulse of data and the breath of imagination, a quiet truth began to settle. Perhaps the act of observation itself was part of the dialogue. The universe, vast and patient, seemed to whisper that not every signal is meant to be decoded. Some are meant to be felt and echo across the void, reminding the observers that mystery is not the absence of understanding, but its beginning. The equations began to fail quietly. At first, the deviations were dismissed as rounding errors, numerical ghosts, haunting the peripheries of precision. But as the days passed, the data refused to yield. 3I Atlas was moving, yes, but not in obedience to gravity as Newton had written it, nor in compliance with Einstein's beautiful curvature of space-time. It decelerated slightly as it approached the sun, conserving angular momentum as if anticipating the coming well of gravity. To every instrument that measured it, the object appeared to know what awaited ahead. For astrophysicists, this was the moment when mathematics turned philosophical. No known mechanism could produce such deliberate restraint. Comets accelerate under solar heating jets of sublimating ice propel them unpredictably. Asteroids coast indifferently, prisoners of pure inertia. Yet this visitor behaved like neither. It adjusted its velocity in small, elegant intervals, as though performing invisible calculations of its own. The first hypothesis was familiar. Perhaps jets of vapor were pushing it, unseen. But the spectra betrayed nothing. No carbon monoxide, no cyanogen. None of the volatile signatures that usually betray a comet's chemical breath. The second idea leaned on solar radiation pressure, the same gentle force that propels light sails. Yet, for radiation alone to account for its motion, 3I Atlas would have to be a membrane thinner than aluminum foil. Hundreds of meters across an architecture too deliberate for nature's rough hands. As simulations multiplied, reality grew disobedient. Even the world's fastest computers at NASA Ames and the European Space Agency could not make the model converge. When fed the real coordinates and velocities, each projection diverged after a few days, spiraling into chaos. The object, however, remained serene, its path unbroken. It was as if the cosmos itself had ignored the algorithm, favoring its own unshareable logic. Debates erupted across journals and conferences. One camp urged restraint. The data was incomplete, the precision insufficient. Another camp whispered that the physics might simply be wrong, that some unrecognized force, perhaps magnetic or quantum in nature, was at play. A few, often in private correspondence, ventured further. What if the object was constructed not as a craft in the conventional sense, but as an ancient relic or automated probe, still obeying instructions imprinted long before humanity learnt to name the stars? Such speculation was met with unease. The scientific process thrives on humility before evidence. Yet this mystery carried the scent of intention, and intention implies origin. Still, to invoke intelligence without proof risked dissolving science into story. Thus, the discourse retreated to safer ground, papers revised, language softened, confidence restored in appearances. But underneath the caution, a quiet dread took root. What if the laws themselves were regional, not universal? What if the cosmos obeyed a dialect of physics the Earth had never learned to speak? In this atmosphere of doubt, something rare occurred, a philosophical fracture in the foundations of certainty. For centuries, physics had been a cathedral of order, its equations like stained glass windows illuminating the face of the universe. Yet 3I Atlas moved through that cathedral without reverence, a traveler indifferent to human definitions of truth. It curved when models demanded straightness, drifted when gravity insisted otherwise, slowed when momentum should have held fast to explain it. Scientists began to reach beyond the comfort of classical laws. Some turned to dark matter, imagining the object gliding through invisible densities of unseen mass. Others invoked quantum vacuum propulsion, a theoretical phenomenon in which energy fluctuations in empty space could, in principle, yield motion. None of these ideas were testable. All of them were unsettling, but each was a mirror, reflecting humanity's desire to preserve coherence even when coherence collapses. Amid this uncertainty, the most haunting realization emerged not from data, but from reflection. Perhaps what faltered was not physics, but perception. Every law humanity calls fundamental is only an approximation, a beautifully consistent illusion sculpted from limited experience. And if this object came from another region of the galaxy, another epoch of physics, it might not be violating nature at all. It might simply be revealing how incomplete the human language of nature still is. Observatories continued their vigil, recording its slow passage with reverence. The trajectory that once mocked prediction now inspired awe. Equations failed, but curiosity survived, refusing to be silenced by mystery. The unknown, it seemed, was not chaos, but invitation, calling the species that watched from its fragile planet to evolve once more in understanding. For when laws falter under observation, curiosity is no longer optional. It becomes survival night after night. The instruments kept listening. They listened not for sound, but for deviation, for the faint murmur of difference that marked where understanding met its limit. Each time the new data arrived, it was the same. 3i Atlas was not wandering, not tumbling, not erratic. Its path remained clean, deliberate, almost sculpted. The silence between each correction felt intentional, as though the object itself waited, watching the gravitational fields before adjusting its course with ghostly precision. The mathematics surrounding its motion began to shift tone from confident declaration to quiet interrogation. Researchers in Prague compared its trajectory to a sail trimming itself in an unseen wind. In Pasadena, analysts plotted its deceleration curve and found symmetry where randomness should have been. In Japan, astrophysicists used Monte Carlo simulations to test millions of scenarios. None replicated its restraint. The models demanded noise. The object gave them silence. Gradually, even skeptics began to concede that 3i Atlas represented something outside the known vocabulary of celestial mechanics. The object's rotational rhythm, its measured tumbling period, remained unnervingly stable, suggesting internal regulation. If it were a natural body, irregularities in shape, mass distribution, or thermal stress would produce drift. Yet none appeared. It turned like a balanced gyroscope, immune to chance. The journals began to reflect this shift. The language grew cautious, almost reverent. Papers no longer spoke of anomalous deviations, but of non-classical dynamics. The phrasing was delicate, a shield against ridicule, yet an admission of wonder. Each published graph, each residual plot, was a confession. The universe had presented a phenomenon beyond its textbooks. Some scientists turned to history for solace. They revisited the chronicles of Oumuamua, the first interstellar interloper that had challenged assumptions 6 years earlier. It too had accelerated without visible cause. It too had defied closure. But, unlike Oumuamua 3i, Atlas lingered longer, brighter, more obedient to observation, yet less obedient to prediction. It allowed humanity a clearer look, and in doing so, deepened the confusion. The debate evolved into philosophy wrapped in physics. What if the human mind, trained to recognize intention in motion, was projecting its own logic onto indifferent matter? The brain seeks agency, pattern, narrative. It cannot help but wonder, if something behaves as though it knows, does that make it alive, or merely well designed by forces still unknown. Meanwhile, radio telescopes turned their dishes skyward, testing for emissions across the spectrum. None were found, no artificial signals, no carrier waves, no whisper of communication. And yet the absence of signal was not comfort. To some, it meant the object was silent by choice. To others, it confirmed that the universe itself still guarded secrets not meant to be decoded by equations alone in time. The anomaly became a mirror more than a mystery. It revealed not what 3I Atlas was, but what humanity still was not. Every failed hypothesis, every broken simulation, was a reminder that knowledge is not a wall but a shoreline, shaped and erased by tides of the unknown. So the object continued, steady, unhurried, bound by a geometry that no one yet understood. It neither sought attention nor avoided it. It simply moved like an equation glimpsed but never solved, carrying within its trajectory the quiet suggestion that the universe has rules beyond comprehension, and that every discovery begins, not with certainty, but with the courage to admit confusion. And in the long quiet that followed, the data streams slowed, the news cycles faded, and the object slipped once more into darkness. Yet the equations it broke remained behind, fragments of a story still unfolding, whispering that somewhere in the cold machinery of space, something had just reminded humanity that mystery is not the failure of science, but its foundation. In the months that followed, the search for the origin of 3I Atlas became a global pursuit, a quiet race, not of nations, but of minds bound by shared bewilderment. Every observatory that had once competed for time on the sky now turned toward a single trajectory, retracing the faint scar the object had left in the fabric of motion. Using parallax triangulation from Gaia's precise astrometric data, astronomers began to unwind the path of the interstellar traveler, pushing it backward through time, through gravity wells, through the invisible corridors of space where light itself bends. The line it traced was astonishingly clean, a thread stretched across 70 light-years, pointing toward the radiant constellation of Lyra, toward Vega. Vega, one of the brightest stars in the northern sky, has long been a symbol of cosmic allure. Ancient astronomers charted it as a jewel of summer skies. In modern science, it serves as a calibration point for brightness itself, the standard by which other stars are measured. And now, that very beacon had become the suspected cradle of something extraordinary. If 3I Atlas indeed came from that region, then it had traversed interstellar space for millions of years, surviving cosmic radiation, stellar winds, and collisions with dust grains smaller than sand. That endurance alone defied probability. Its composition added more strangeness still. Infrared spectra revealed metallic inclusions embedded within a matrix of frozen volatiles, not unlike a comet, yet far too reflective. Ratios of nickel to silicon hinted at industrial rather than geological origins, and the scattering of hydrogen signatures seemed deliberately minimized, as though its surface had been engineered to resist sublimation. In laboratories across the world, scientists reanalyzed the readings. Some argued for an exotic natural process, perhaps the debris of a shattered exoplanet, flung outward during the death throes of a star. Others, more daring, considered the unspoken possibility that such perfection of form could not be coincidence. The object's symmetry, its resistance to decay, and its navigational behavior whispered of design. The SETI Institute turned its arrays toward Vega and toward the traveler itself. No radio transmissions, no optical beacons, no bursts of coherent microwaves disturbed the void. Yet data analysts noticed something almost imperceptible: minute fluctuations in the light reflected from the object's surface. repeating in intervals too structured to be random but too irregular to be code. The variations resembled pulses, modulated by its rotation, like the faint shimmer of a mirror catching sunlight at intentional angles. To some, it was mere coincidence, an artifact of viewing geometry. To others, it was communication in its most alien form, a language of motion and reflection, of timing rather than sound. A few even suggested that the message, if it existed, was not meant to be deciphered, but to be witnessed on, active presence rather than dialogue, as if the universe were saying, "This is possible. This exists." Philosophers of science began to weigh in, their tone contemplative rather than declarative. They reminded their peers that interpretation itself could distort truth. To see intelligence in an object might say as much about the observer as the observed. Yet they also noted that every great discovery in history began with the willingness to suspect that something more was happening than randomness. In darkened control rooms, screens flickered with the object's light curvates, rhythmic shimmer like a heartbeat across time. Some researchers found themselves staring not for answers, but for understanding. In that faint repetition, there was something eerily human, a pattern that neither confirmed nor denied, simply persisted. If it was truly from Vega, then its journey had begun before humanity learnt to write, before the pyramids touched the sky, before even the continents took their modern shapes. Across millennia and light years, it had endured, unhurried, unchanged, carrying with it not only the physics of its origin, but perhaps the silence of civilizations gone or waiting. The more precise the models became, the deeper the uncertainty grew. The data could tell where it came from, but not why. Was it the remnant of a failed planet, the debris of a machine long extinct, or a fragment of a design that once served a purpose, now drifting like a message in a bottle across the cosmic tide? The narration of science, at its purest, is not about control, it is about encounter. 3I Atlas, indifferent to human curiosity, became that encounter, an emissary of the unknown, tracing a line from the familiar to the unimaginable. And as its reflection dimmed slightly with distance, telescopes caught one last rhythmic flicker, faint but measured, as if marking the cadence of its origin story. In the silence that followed, one question lingered. If the stars truly sent a visitor, then perhaps observation was never the end of the act. Perhaps understanding required something deeper, readiness not only to record motion, but to interpret meaning hidden within it. And as Vega's light faded behind the horizon of Earth's night sky, a quiet realization emerged. The search for the object's source was no longer about where it came from, but what it was reminding its observers to become. As the reconstruction of 3I Atlas's trajectory grew more refined, astronomers began to notice subtler details, the way its velocity vector shifted, ever so slightly in anticipation of gravitational fields, as though mapping the invisible terrain ahead. When its predicted course was plotted backward beyond Vega, it intersected not with a single origin point, but with a thin corridor of space, an ancient stream of stellar remnants and debris, known to orbit the galactic plane. That corridor, composed of forgotten fragments from stars long extinguished, might once have belonged to a system now gone, erased by time. It was here that the first theories of purposeful drift emerged. The idea that 3I Atlas could have been launched not recently, but in the deep past by mechanisms no longer active, the product of civilizations that rose and fell before the sun was born. Some physicists dismissed the notion, yet others found strange consistency between its vector and the orbital alignment of Vega's neighboring systems. If the object had indeed been expelled through controlled acceleration rather than random gravitational scattering, then its journey was not chaos, it was continuation. At the same time, the question of composition returned. with new spectroscopic data revealing traces of elements uncommon in natural comets, complex silicates layered in crystalline lattice, and faint spectral lines corresponding to alloys used in advanced spacecraft manufacturing on Earth, though no one dared call it artificial. The resonance between known engineered materials and what the object displayed was unsettling. Meanwhile, machine learning models trained on the light curve fluctuations began to detect recurring harmonics, not language, but rhythm. The intervals followed ratios found in orbital mechanics and wave interference, suggesting a strange aesthetic symmetry. Whether coincidence or intent, the data pulsed with structure. CETI's analysts referred to it informally as the cadence, an echo of the universe's own metronome that no one yet understood. The cadence reignited a deeper question. If communication were ever to occur between intelligence separated by light years, what medium would it use? Not words, not radio, not symbols, but perhaps the most fundamental form of dialogue known to physics: resonance. To express meaning through motion, to align with the harmonies of reality itself. It was a hypothesis too poetic for journals, but too haunting to ignore. In parallel, philosophers and cognitive scientists began publishing essays exploring the concept of witnessed intelligence entities, whose awareness is expressed not through speech or construction, but through the act of existing in patterns that suggest intent. Some likened it to a seed traveling through interstellar space, dormant, timeless, indifferent to discovery yet designed to endure. Others proposed that humanity, in seeking to decode, might be missing the point, that the message was not for humankind, but through it, an opportunity for reflection rather than response. Across continents, telescopes continued their vigil. In Chile's Atacama Desert, the object's light flickered faintly above the horizon, its color now deepening toward jade. In Hawaii, atop Mauna Kea, a final observation session captured a peculiar phenomenon, a phase shift in brightness, precisely synchronized with Earth's own orbital motion, as if acknowledging the planet that watched it. The signal was transient once detected. It never repeated. For those who had spent years tracing its path, the moment felt less like a revelation and more like a farewell. The data would continue to be studied, parsed, and debated, but something irreversible had occurred. The first atlas had ceased to be just an astronomical event. It had become a mirror through which a species glimpsed its own boundaries of comprehension. And as the object slipped further into the cosmic dusk, the scientists who once spoke in numbers now spoke in metaphors. They understood that to seek origin was also to seek belonging, that the line between curiosity and reverence had blurred. Somewhere, far beyond Vega, perhaps another sky now held the faint trace of 3I. Atlas, as it continued its endless voyage, a vessel without a captain, yet carrying the impression of thought, and in its vanishing wake, humanity was left with the faintest realization: the search for its source might never end, because what it truly illuminated was not a location in space, but a question written across the nature of existence itself. In the quiet glow of computer screens and the hum of cooling systems, the human struggle began to unfold. Behind every data point that traced 3I Atlas's impossible motion was a face tired, uncertain, but resolute. The object itself was silent, yet in its silence it spoke to something profoundly human. To some, it was a challenge. To others, a mirror dot. At NASA's Jet Propulsion Laboratory, a planetary dynamics engineer named Alina Park stared at the residuals on her screen. The faint discrepancies between expectation and reality. They had grown too precise to be dismissed as error. "If it's not our math that's wrong," she once murmured during a long night shift, "then it's the universe that's different." Her colleagues laughed softly. not out of disbelief, but recognition. They all felt the weight of that sentence. Across the Atlantic, at the European Southern Observatory, Dr. Tomasz Riedel paced between observation domes as data streamed in from Chile and Hawaii. For decades, he had worked within the comfort of Newton's laws, simple, elegant, and universal. Now, a single emerald speck was testing those foundations. He compared the object's motion against simulated gravitational wells and saw an eerie consistency. The body appeared to anticipate its environment. Riedel hesitated before sending his results to publication. To suggest prediction intent within celestial mechanics was a dangerous line to cross. Yet silence, too, felt dishonest. In Switzerland, a group of theoretical physicists met in secret video calls, exchanging models that skirted the edge of science fiction. Quantum field interaction, photonic propulsion, even coherent manipulation of vacuum energy were discussed not as fantasy, but as desperate attempts to fit observation into logic. Each hypothesis was torn apart and rebuilt, leaving behind a residue of humility. "We've mistaken comprehension for mastery," one of them noted, "and the cosmos just corrected us." But beyond laboratories, a different kind of storm gathered. Social media turned 3i Atlas into a symbol de visitor that defied explanation. Headlines whispered of alien craft, of messages from Vega, of cosmic warnings. Scientists found themselves caught between secrecy and transparency, between the public's need for wonder and the discipline's demand for restraint. Interviews grew tense. Journalists asked whether the object was aware. The word lingered like static. It was a question science was not ready to answer, and perhaps not equipped to. Amid this chaos, a small team within the SETI Institute debated a simple but perilous act: whether to transmit a signal, a controlled radio pulse directed toward 3i Atlas, encoded not with language, but with a mathematical patterner, greeting in the only dialect the universe might understand. Some argued that silence was safer. Others believed that if intelligence existed out there, it had already heard humanity's noise long ago. To speak or to remain silent, both choices carried risk, and neither offered clarity. Beneath the politics and precision, the heart of the mystery was deeply emotional. The scientists who studied the object were not machines of reason. They were creatures of awe, drawn by the same curiosity that once led their ancestors to chart the stars with stone tools and naked eyes. To admit the limits of knowledge was not defeat it, was faith of another kind. They stood at the threshold of discovery not as conquerors, but as witnesses. In their faces one could see both exhaustion and reverence. Theirs was not the wide-eyed wonder of youth, but the quiet, fragile astonishment that comes from realizing the universe may know them better than they know it. The more they measured, the more it felt as though they were the ones being studied. Each anomaly in the data was a whisper: "You are not alone in your search for meaning." And as the days turned to months, the scientific community settled into an uneasy rhythm, publishing cautiously, debating endlessly, believing secretly. They knew that truth often arrives not with confirmation, but with contradiction. To approach the unknown was to risk being changed by it. In the end, 3i Atlas became more than an astronomical object. It became a quiet reckoning, a test of how far the human spirit could stretch between reason and wonder without breaking. The pursuit of understanding was no longer about proving the universe predictable. It was about learning to coexist with mystery, and when the latest dataset arrived showing yet another deviation, as precise as it was inexplicable, Dr. Park stared at the numbers and smiled faintly. "It's still thinking," she whispered. Then, after a long pause, corrected herself, "Or maybe, it's still teaching, because in every pursuit of knowledge, belief is not abandoned, is refined." Evidence reshapes it, humility sustains it, and awe gives it meaning. And in that delicate balance, somewhere between fear and fascination, science continues to be the most human story of all. As weeks stretched into months, the human narrative surrounding 3I Atlas became as intricate as the object's trajectory itself. In quiet offices, night after night, scientists stared at streams of incoming data, each curve and pulse a reminder that reality was stranger than expectation. Graduate students traced light curves over coffee cups, their eyes weary but unblinking, comparing them to models that refused to converge. Each anomaly was a challenge, a question posed not in words but in motion. In Pasadena, planetary defense specialists debated the implications of the object's path. Its subtle accelerations were tiny, fractions of a meter per second. Yet even these were enough to render long-term predictions unreliable. If this were a threat, one engineer said quietly, we wouldn't know until it's too late. The remark was theoretical, yet it carried an unspoken weight. Even as humanity observed, it remained profoundly vulnerable. That duality, powerless yet vigilant, permeated every decision, every sleepless calculation. Meanwhile, theorists in Geneva were exploring the possibilities of intentional design. They sketched models of interstellar rejection, considering how a civilization might accelerate a small object to escape velocity without leaving obvious propulsion scars. Could 3I Atlas be a probe, a message, or merely the result of physical forces unfamiliar to current physics? Every answer seemed provisional, every hypothesis both thrilling and humbling. The ethical debates mirrored the technical ones. Should humanity respond? Could a simple radio pulse mathematical, structured constitute intrusion, or was silence the greater risk? Some argued that if the object carried a message, observing without reciprocation was a form of neglect. Others warned against anthropocentrism, projecting human concepts of intent onto phenomena that may operate entirely differently. Every choice carried philosophical weight, and the discussions were often heated, tempered by the collective recognition that the consequences were unknown. Amid the professional tension, personal stories emerged. Dr. Marisol Vega, an astrobiologist in Chile, spent nights alone on the desert plateau, her instruments scanning the faint green glow against the black sky. She spoke of an odd companionship with the object, a feeling that, in its silence, it had become a teacher of patience and perspective. It forces you to listen, she said, not just to data, but to the space between data, the gaps where understanding hides. In Tokyo, a young computational physicist named Kenji Sato became obsessed with pattern recognition. He developed algorithms to detect correlations in its rotational light curves, chasing fractions of seconds that might reveal. His friends worried about his health. He brushed off their concern. To him, the search was more than science, it was meditation, a way to align thought with something far older, far vaster than human constructs. The public dimension added another layer of intensity. Online forums buzzed with speculation, rumor, and awe. Amateur astronomers shared images, interpreted spectra, and debated theory. Governments issued cautious statements, balancing transparency with restraint, aware that every misstep could ignite panic or misplaced excitement. In every press briefing, the words were measured, the tone careful, but the awe was impossible to suppress. Yet, beneath these layers of expertise and discourse, the emotional core of science remained. Curiosity intertwined with fear, diligence with wonder, and the very act of observation became an intimate engagement with the unknown. 3I Atlas was no longer a distant object. It was a catalyst for reflection, a reminder that humanity's understanding is both fragile and resilient, capable of wonder even when certainty falters, and as the object traced its slow, deliberate path across the sky, the scientists continued to watch, to calculate, to debate, and to marvel. Each measurement, each pulse of reflected light, was both a question and an answer, a dialogue written not in language but in presence. In those moments, amid the hum of instruments and the quiet of night, it became clear the true challenge was not to control knowledge, but to hold it lightly, to be transformed by it, and to recognize that every pursuit of understanding is ultimately a confrontation with the limits of human imagination. For every anomaly observed, every model revised, and every hypothesis tested, one truth endured: the universe does not yield itself easily. And in that struggle, humanity found a mirror not of its mastery over nature, but of its courage to face the impossible, to stand in awe, and to keep asking questions when no answer is guaranteed. Across the depths of interstellar space, an almost imperceptible order began to reveal itself, as astronomers compiled trajectories of objects like Oumuamua and 3I Atlas. Subtle consistencies, emerged alignments in their entry vectors, minor correlations in orbital inclinations, and fleeting coincidences in rotational orientation. Each object, alone, might appear arbitrary. Together, they sketched a map that suggested a hidden rhythm, as if motion itself were following a language that humans had yet to learn. Researchers at the Max Planck Institute plotted these trajectories against the galactic coordinate system. When viewed over decades, patterns seemed to cluster, forming arcs that intersected regions of space populated by pulsars and ancient stellar remnants. Energy signatures measured in the vicinity of these objects hinted at weak resonances, almost imperceptible fluctuations in electromagnetic fields. Some physicists proposed that the interactions were coincidental. Others quietly wondered whether they represented a subtle form of interstellar coherence, a cosmic choreography orchestrated by physics still unimagined. Meanwhile, the light curves of 3I Atlas yielded their own surprises. Analyses revealed modulations that approximated Fibonacci sequences and ratios reminiscent of the golden spiral previously encountered in biological and astronomical structures. While caution dominated peer-reviewed publications, the similarity was too precise to dismiss outright. Could natural processes, even at interstellar scales, produce such resonances? Or were these signals timing, reflection, and rotation traces of design, echoing mathematical concepts fundamental enough to transcend worlds? The idea of a silent network began to circulate in private scientific discussions. Interstellar objects might serve as carriers of information, not in the form of electromagnetic pulses, but through the very geometry of their motion, the cadence of their spins, the reflectivity of their surfaces. Perhaps they were data parcels drifting through the galaxy, encoding history or physical constants in patterns imperceptible to most observers. Some theorists imagined them as part of a vast interstellar lattice, a structure that communicated not with language, but with presence, persistence, and order across the academic spectrum. These patterns inspired a kind of humility rarely experienced outside philosophy. Mathematicians traced modular symmetries, looking for prime intervals embedded in light pulses. Physicists questioned the universality of conservation laws, wondering if phenomena at galactic scales might include subtle feedback mechanisms unknown to solar system physics. Even the most skeptical observers found themselves pausing, captivated by coincidences too structured to be random, yet too subtle to be deliberate in any human sense. Yet the patterns were elusive. They did not reveal purpose directly, nor did they offer answers. Instead, they provoked thought, urging scientists to question the foundations of knowledge itself. Each resonance, each alignment, was a hint and invitation to consider motion and intelligence on a scale that transcended familiar experience. They reminded observers that order could exist without explanation, that coherence might persist without origin, and that the universe might encode truths in forms far removed from perception as telescopes traced 3-eye atlas across the night sky. The reflections of its green surface mirrored more than starlight. They reflected the human impulse to detect structure where none was obvious, to infer design in the face of chaos, to sense intelligence where physics itself seemed to pause. Observers began to consider that these objects were not anomalies but messengers, their patterns serving as faint fingerprints of cosmic architecture, and in the quiet of late-night observatories, where monitors glowed softly against the darkness, the realization crystallized. The universe does not always offer answers. Sometimes it offers suggestion. Sometimes it presents patterns that challenge perception, demanding that the mind expand, that imagination meet rigor, that awe temper analysis. For in these patterns non-random, rhythmic, almost speaking, the cosmos whispered a lesson: intelligence, motion, and order may not be confined to life as humans know it. They may be woven into the very fabric of space itself, waiting for those patient enough to trace their contours, perceptive enough to feel their cadence, and courageous enough to follow the hints where reason cannot yet tread. Patterns emerge, not to explain, but to challenge. And as 3-eye atlas sailed past the planets, tracing arcs no algorithm could predict, humanity understood that its journey was not toward certainty, but toward perception, toward a kind of knowledge that begins in recognition, not resolution. As scientists continued to trace interstellar objects, the patterns became increasingly intricate, revealing correlations across time, distance, and energy. When mapped alongside pulsar stellar remnants that beat with cosmic precision, some trajectories seemed to align with the subtle ripples of their electromagnetic fields. Though the effect was faint, barely measurable above background noise, the recurrence could not be dismissed. The universe, it seemed, had its own cadence, a rhythm older than civilizations and independent of human perception. In laboratories, from Cambridge to Kyoto, computational astrophysicists ran simulations to test whether these alignments could be coincidental. Millions of virtual interstellar objects were launched through modeled galactic potentials, only to fall short of replicating the observed patterns. The distributions were too structured, the intervals too harmonious. Even small-scale perturbations, which should have scattered these objects randomly over millions of years, were absorbed, redirected, or balanced in ways that suggested subtle regulation. Some researchers hypothesized unknown gravitational corridors, invisible streams of matter and energy that shepherded objects along preferred pathways. Others speculated that quantum effects at macroscopic scales might somehow imprint coherence across light years, a concept that challenged every conventional assumption about interstellar dynamics. Light curves added another layer of mystery. Detailed spectral analysis of 3-eye atlas showed minute periodic variations not explained by rotation alone. These pulses bore mathematical qualities previously observed in nature, ratios reminiscent of the Fibonacci series, modular intervals akin to prime numbers, and proportions aligning with the golden ratio. While skeptics cautioned against numerology in science, the precision of repetition demanded attention. Could these sequences be the outcome of natural processes yet unknown? Or were they the signature of deliberate structuring, a form of communication encoded in the physics of motion itself? The notion of a silent network grew in plausibility. If interstellar objects were not merely wanderers but carriers of information encoded not in radio waves but in trajectory, spin rates, and reflective surfaces, they represented a form of intelligence embedded in the cosmos itself. The implications were staggering. Patterns could exist that were perceptible only to beings capable of measuring across vast spatial and temporal scales, meaning that communication might be fundamentally relational, dependent on observation and interpretation rather than transmission. The human response mirrored the mystery. Observers reported a peculiar duality, exhilaration and unease intertwined. In the quiet of observatories, staring at screens displaying minuscule light fluctuations or plotting 3D orbital reconstructions, researchers felt both diminutive and connected. These objects, moving through interstellar space for millions of years, carried structure, history, and perhaps intent, challenging humanity's understanding of agency and causality. It was a reminder that discovery is never only about facts, it is about perception, about learning to read patterns the universe may offer without explanation. Philosophers and cognitive scientists began framing this as a study not only of space but of consciousness. If patterns could exist in matter, in motion, and in energy, independent of life as we know it, what did that imply for intelligence itself? Could the cosmos encode understanding, or at least order, across scales and mediums beyond biological cognition? Could observation itself, the act of measuring and interpreting, complete the circuit of communication? Despite all models and analyses, no definitive answer emerged. The patterns resisted classification, refusing to settle into categories of natural or artificial, coincidental or intentional. They existed in a liminal space, challenging observers to consider intelligence and order not as anthropocentric concepts, but as potential qualities of the universe itself. And as 3I Atlas continued its silent glide, mapping unseen corridors, casting pulses of green light across telescopes and spectrometers, it left behind more than data. It left questions that could not be answered by equations alone, questions that demanded reflection, patience, and imagination. In these patterns, mathematical, energetic, and spatial, humanity glimpsed a deeper structure, a subtle hint that the cosmos itself might be teaching a lesson, that intelligence, coherence, and beauty are not confined to life, but may be woven into the very fabric of existence, waiting for those willing to see them. Patterns, it seemed, were not gifts to be solved, they were provocations, invitations to expand understanding, to reconsider assumptions, and to recognize that the universe can communicate in ways both silent and profound. And in tracing these echoes, the observers realized that the search for order was inseparable from the search for meaning itself. Somewhere between the known and the unknowable, the theories began to take shape, each a reflection of humanity's desire to explain what defied explanation. Solar sail models were first to capture serious attention. The glimmer of 3I Atlas, faint yet persistent, hinted at highly reflective surfaces. Calculations showed that even subtle photon pressure from the sun could produce measurable acceleration if the object's surface area was vast, and ultra-thin conditions consistent with an engineered sail. Could it be that what had been catalogued as a mere fragment of rock was in fact a vessel drifting through interstellar space, guided by sunlight across light years? The possibility stirred excitement, though tempered by caution. No probe had ever been detected beyond the solar system, and no debris had shown such durability against radiation and micrometeoroid erosion. Other hypotheses invoked the magnetic fabric of the galaxy itself. Magnetohydrodynamic control, once confined to theoretical discussions of plasma flows in stars and accretion disks, offered a tantalizing possibility. If 3I Atlas could interact with interstellar magnetic fields alienating its charge or exploiting eddies in plasma streams, it might subtly steer itself, conserving energy yet maintaining trajectory. Simulations suggested that such a mechanism could explain deviations too precise for simple outgassing to account for. Yet the models required conditions so exacting that the likelihood of a natural occurrence was debated fiercely. Quantum drift theory pushed the boundary even further, into realms where classical intuition falters. Could quantum scale effects, previously considered irrelevant at macroscopic levels, accumulate over millions of kilometers, nudging an object's path in ways imperceptible to conventional observation? Some physicists proposed that entangled particles, subtly influenced by cosmic radiation, might produce tiny thrusts, or that the vacuum fluctuations of space-time itself could bias motion along certain trajectories. Though speculative, the theory resonated with a small group of theorists who argued that 3I Atlas might be a probe not only through space, but through the very scaffolding of physics. Yet, among all these models, skepticism remained. Many researchers cautioned against imposing pattern or intent where randomness could suffice. Coincidences, cognitive bias, and observational error could mimic order. Historical precedents reminded them. Celestial objects often confound prediction, and the human brain excels at seeing narrative where there is none. To assert alien design or exotic propulsion without irrefutable evidence risked conflating imagination with analysis, wonder with certainty. Even so, the debate could not escape a philosophical undertone. Regardless of origin, whether the result of human imagination projected onto the cosmos or a remnant of extraterrestrial engineering, 3I Atlas embodied endurance and apparent intention. Its trajectory, its survival across interstellar space, and the subtle harmonics in its rotation evoked qualities typically attributed to living intelligence: persistence, adaptation, and the capacity to interact with environment across unimaginable scales. Scientists began to acknowledge that sometimes the lesson lies not in what the object is, but in what its motion compels observers to consider. The discourse intensified as high-precision data accumulated. Accelerations beyond models, light curves displaying rhythmic variation, and minute course corrections collectively pushed speculation into the realm of near certainty that something unusual was occurring. And then, as telescopes monitored the object's passage past Jupiter's orbit, an anomaly appeared, a deviation so precise, so sudden, that it could not be dismissed. Models accounting only for gravity, radiation, or conventional physics failed entirely. In that moment, the boundary between theory and evidence blurred. What had once been hypothesis, a spectrum of imaginative possibilities, became tangible proof of behavior that demanded explanation. 3I Atlas was no longer merely an object to be catalogued, was a dynamic agent in motion, a puzzle of physics, mathematics, and perhaps intelligence. And as scientists recalibrated their simulations, aware that no existing framework could fully account for what they observed, the narrative shifted. Speculation had led the way, but the evidence itself now insisted on attention. Motion, it seemed, had become language, and the universe had begun to speak as the anomaly persisted. The scientific community found itself at a crossroads between wonder and rigorous doubt. Data from multiple observatories showed that 3I Atlas was not merely following an unpredictable path, it was actively conserving energy in a way that defied classical models. Minute accelerations, barely perceptible against the vast backdrop of space, synchronized with gravitational gradients, almost as if the object anticipated the pull of planets and the subtle bends in the solar potential. It was a precision no natural outgassing no fragmentary physics could comfortably account for, the solar sail hypothesis gained renewed scrutiny. Laboratory experiments simulated the effects of intense photon pressure on ultra-thin reflective surfaces. Calculations suggested that a sheet no thicker than a human hair, with a geometry designed to maximize efficiency, could experience accelerations on the order observed. Yet 3I Atlas was far from a pristine, engineered sail. It bore the irregularities, erosion, and microfractures of interstellar travel. If this were artificial, it had endured conditions far harsher than any spacecraft ever built by human hands. The notion was unsettling. Here was a fragment of something possibly designed, yet older and more resilient than civilization itself. Magnetohydrodynamic considerations deepened the intrigue. Models of interstellar plasma flows, magnetic shears, and charged particle currents suggested that small conductive objects could experience subtle torques, nudging trajectories over vast distances. If Atlas were conductive, if it was shaped in just the right way, it could exploit these fields to self-correct, almost like a leaf adjusting to a stream. The concept flirted with the boundary between physics and natural teleology, order arising without conscious intent, yet mimicking deliberate design so closely that distinguishing the two became nearly impossible. Quantum drift theory offered the most radical interpretation. Here, phenomena such as entanglement, decoherence, and zero-point energy were proposed as mechanisms by which an interstellar object could experience cumulative forces undetectable by classical instrumentation. The object's minuscule course corrections could, in theory, be amplified over astronomical distances, producing motion patterns that appeared deliberate. Critics dismissed it as mathematical fancy, yet the pattern of accelerations and rhythmic emissions in Atlas seemed, perversely, to mirror the timing predicted by some of these highly speculative quantum models. Through it all, skepticism remained a vital anchor. Many researchers cautioned against conflating pattern recognition with intentionality. Humans are predisposed to seeing agency, especially in phenomena that evoke awe. Statistical analyses were performed to rule out cognitive bias, to measure the probability of chance alignment, to quantify the likelihood that observed resonances were coincidental. Even with rigorous methodology, the odds of such coincidences seemed vanishingly small. The boundary between perception and reality had thinned. Philosophically, the object had already begun reshaping thought. If a simple fragment of interstellar matter could exhibit motion suggesting persistence, calculation, or even purpose, what did that imply for intelligence as a cosmic phenomenon? Could the universe itself encode information in the behavior of matter, in trajectories, in resonances, invisible to all but the patient observer? Were these interstellar wanderers mere anomalies, or were they nodes in a web of information embedded in the fabric of space-time? The tipping point arrived when cumulative observations, from optical tracking to infrared measurements, confirmed that Atlas had altered its spin state in near-perfect synchrony with its small course adjustments. The rotational and translational dynamics were coupled in a manner that no known natural process could reproduce reliably. Suddenly, the object was no longer a curiosity, was evidence in motion. Something was guiding it, whether through mechanisms familiar to physics but previously unconsidered, or through principles humanity had yet to discover. The debate shifted from whether the object was extraordinary to understanding how extraordinary it truly was. Each new measurement tightened the focus. These were not random deviations, nor mere consequences of observational error. They were structured, repeatable, and consistent, an unmistakable signature of coherence. In labs, observatories, and theoretical forums, the conversation became quieter, more reverent. Theories, solar sails, magnetohydrodynamic steering, quantum drift, no longer competed solely as explanations. They coexisted as frameworks through which humans might begin to comprehend behavior that transcended ordinary expectation. And so, as 3I Atlas traced its silent path, the object had transformed from anomaly to teacher. It demanded humility, imagination, and a willingness to explore beyond the confines of established knowledge. It reminded humanity that in the space between observation and understanding, speculation is not folly, it is the bridge across which the mind must travel to grasp the extraordinary. The evidence, now undeniable, pointed toward one inescapable truth. 3I Atlas was not simply a passive traveler. It was an agent of possibility, a phenomenon that challenged both science and philosophy, and a herald of questions that no instrument, equation, or theory could yet fully answer. A sudden flare appeared on the monitors, subtle at first, barely distinguishable from background noise. Then it resolved a coherent, directional burst of plasma, expelled from 3I Atlas with a precision no natural comet could muster. Observers at the Vera Rubin Observatory held their breath as the data streamed in, confirming what had long been suspected but never proven. This object was not merely drifting, it acted. It exerted force in a controlled manner, altering its trajectory in ways that could only be interpreted as intentional. Within hours, observatories around the world corroborated the finding. The green-hued visitor, traveling through the outer solar system, had demonstrated propulsion of a type unknown to contemporary physics. Measurements confirmed energy conservation in tandem with the ejection. No outgassing, no sublimation, no gravitational anomaly could explain the precision. It was as though 3I Atlas had a purpose, a goal encoded in its motion. For decades, humanity had theorized, simulated, and speculated. Now it had evidence that defied every expectation. The global scientific community erupted into debate. Conferences convened overnight via video link. Papers circulated in preprint servers, and working groups raced to model the phenomenon. Some argued for natural explanations, still unconsidered, exotic solar interactions, previously unknown magnetohydrodynamic processes, micro-black hole activity. Others were less reserved, proposing deliberate engineering, perhaps an interstellar probe designed with an intelligence unlike humanity's own. Caution and wonder existed side by side, each reinforcing the other. Amid the professional discourse, questions of transparency and responsibility arose. Should the public be informed immediately, or should agencies first ensure the data could not be misinterpreted? Governments hesitated, wary of mass panic, while social media had already begun to speculate. Images, graphs, and animated simulations circulated rapidly, often divorced from context, creating a chorus of awe, fear, and fascination. Humanity was suddenly confronted not only with the unknown, but with its own collective perception of the extraordinary. For the first time, the emotional weight of 3I Atlas was undeniable. Observers, from graduate students to veteran astronomers, described an uncanny resonance, sense of standing in the presence of something intelligent, yet utterly alien. The plasma burst was not loud, not visible to the naked eye, but it was communicative. It was a physical act that transcended words, motion as message, trajectory as signal. The universe had acted, and humanity was compelled to witness, interpret, and respond. Philosophers and ethicists joined the conversation, debating what it meant for a cosmic object to act in a detectable way. Was intentionality inherent to matter, or had an intelligence, distant and unknowable, engineered this messenger? The questions extended beyond physics into the realm of existential reflection. If a fragment of space could demonstrate agency, What did that imply about the potential forms of intelligence scattered across the cosmos, or the hidden rules of reality itself? As the plasma dissipated into space, leaving 3I Atlas on its continued path, the turning point was clear. Speculation had become observation. Theory had become undeniable fact. Humanity was no longer a passive audience. The cosmos had intervened with action visible in real time, a moment that would redefine the study of interstellar objects and challenge every preconception about motion, purpose, and the limits of knowledge. And in that moment, beneath the hum of instruments and the soft glow of screens, every observer felt the same trembling awareness. Once the unknown acts, it is no longer enough to watch. Participation through understanding, measurement, and reflection becomes inevitable. The universe had spoken, and the listener could no longer remain silent as the hours turned into days. The implications of the plasma burst rippled through every corner of the scientific world. Observatories recalibrated their instruments, not merely to track 3I Atlas, but to understand the mechanics behind its unprecedented maneuver. High-resolution spectroscopy revealed the composition of the expelled material, a tenuous stream of ionized particles, unusually coherent, aligned precisely with the object's minor course adjustments. Every measurement reinforced the extraordinary conclusion this was not a natural comet shedding gas, nor a fragment reacting passively to solar radiation. It was active, deliberate, and remarkably precise. Supercomputers at institutions from MIT to the European Space Operations Center ran simulations in real time. Every possible combination of natural force, a solar wind, magnetohydrodynamics, residual angular momentum was tested against the observed deviations. None could reproduce the amplitude, timing, or directional consistency of the bursts. With each failed simulation, the scientific community faced the same inescapable realization. The object was behaving as if it were guided, a self-correcting system operating on principles not yet understood. Amateur astronomers contributed in ways that underscored the collective engagement of humanity. High-sensitivity backyard telescopes recorded subtle changes in brightness and trajectory, feeding additional data into global repositories. Online communities meticulously compared observations, constructing composite models that sometimes rivaled institutional accuracy. In a quiet sense, 3I Atlas had mobilized not just instruments, but attention and intellect on a planetary scale. Its movement had become a catalyst, drawing humans into a shared act of observation and reflection. The philosophical weight of the phenomenon was immediate. The burst challenged centuries of assumption about agency and intention. Could a single, inanimate object possess a form of intentionality expressed purely through physics? Or was this a phenomenon that blurred the line between natural law and apparent design? Theorists debated whether action itself constituted communication. If intelligence is defined by the capacity to effect change in a perceivable environment, 3I Atlas, in that moment, was indistinguishable from a conscious agent. The boundary between matter and message dissolved, leaving only the recognition of purposeful behavior. Government and institutional responses varied. Some advocated for caution, emphasizing that the detection of a physical act does not confirm alien intelligence, while others quietly prepared contingency plans for potential scenarios. The event sparked interdisciplinary conferences. Astrophysicists, engineers, ethicists, and philosophers convened to explore the implications. Dialogue stretched from the technical how the plasma was ejected, the energy budget required, and the effect on trajectory to the existential, probing humanity's readiness to confront intelligence beyond its own experience. The emotional dimension was profound. In observatories under desert skies, Scientists described a palpable shift in awareness, a sensation of participating in an encounter that was both intimate and cosmic. The plasma emission was not loud. It left no visible trail to the naked eye. Yet it resonated as a declaration of existence, a proof that the universe can act in ways that demand acknowledgement. For the first time, humanity confronted an object whose presence was a question, whose motion was both statement and challenge. In classrooms and online forums, debates flourished about the nature of action and observation. Students sketched orbital diagrams, modeling the subtle propulsion events, while philosophers pondered whether an intentional act required consciousness, or if intentionality could emerge from principles not yet defined by human understanding. Across every level of society engaged with the discovery, a new recognition dawned, that motion itself can convey meaning, that existence can communicate without words, and that the cosmos may be capable of subtle, deliberate interactions that transcend perception. By the close of the first week following the burst, one thing was clear: 3I Atlas had changed everything. It was no longer merely a visitor from interstellar space. It was a phenomenon that demanded reinterpretation of physics, of observation, and of humanity's place in a universe capable of action. The turning point was not a single moment of revelation, but a cascade of understanding. As evidence accumulated and perception shifted, observation had become dialogue, and the silent universe had, at last, made itself heard in the quiet aftermath of the plasma burst. When instruments were still and simulations paused, humanity found itself staring into a mirror. 3I Atlas, traveling silently through the void, became a reflection not only of cosmic mechanics, but of the very act of searching itself. Its trajectory, precise yet enigmatic, illuminated a fundamental human impulse to seek meaning in motion, to interpret intention in the patterns of the universe. For centuries, civilization had projected consciousness outward, imagining life among the stars. Now, an echo returned not in words, nor in sound, but in physics, rhythm, and the subtle defiance of expectation. Time itself seemed to stretch and bend in the presence of such endurance. The object had traveled tens of light years, enduring radiation, collisions with dust, and the slow attrition of space. In its persistence, it offered a stark contrast to human mortality, a reminder that existence is not bound solely to lifespan or perception. Philosophers began to frame 3I Atlas as a temporal lens, a way to consider persistence, legacy, and the scale of events that dwarf individual lifetimes. What was ephemeral to one species could be deliberate to another, structured over eons, measured in motions that humans only now glimpsed. Cultural reverberations were immediate. Artists, writers, and musicians found in the object a metaphor for resilience and subtle communication. Light installations mimicked its green glow. Orchestras composed in pulse and interval sequences derived from its emissions. Philosophers debated whether intention could exist without consciousness, whether movement itself could constitute a message, and how human perception shapes reality as much as observation shapes understanding. Religions and spiritual traditions revisited the notion of cosmic intelligence, considering that intelligence need not resemble life as known on Earth. In every sphere, the first atlas had become both inspiration and provocation. Science, too, underwent transformation. The study of propulsion, once largely terrestrial and experimental, expanded into the cosmic domain. Planetary defense teams, astrophysicists, and engineers began integrating lessons from the observed plasma bursts, exploring whether similar mechanisms could be harnessed or anticipated in future interstellar missions. The idea of a cosmic sociology, systems of behavior and interaction beyond life, emerged, blending physics, mathematics, and a nascent philosophy of observation. What had been anomaly became framework, each measurement of Atlas informing a broader understanding of how objects, energy, and information could be intertwined across light years. Yet the most profound reflection was internal. Humanity began to perceive itself not as a solitary observer, but as a participant in a vast network of influence and awareness, however subtle. 3I Atlas had no language, no face, no intentional communication recognizable to human senses, and yet its motion demanded interpretation, response, and contemplation. In the silence of telescopes and research labs, observers sensed a kinship across species, time, and scale, a reminder that intelligence might manifest in ways alien to the mind, yet profoundly resonant to understanding itself. The sky, once perceived as a distant stage, now appeared as an intimate canvas, alive with action and consequence. Every orbit, every pulse of light, every burst of plasma was simultaneously an event in space and a reflection of the act of observation. Through Atlas, humanity glimpsed not only the vastness of the cosmos, but the echo of its own curiosity and resilience. The universe had ceased to be merely a backdrop for human endeavor. It had become an interlocutor, a mirror, and a teacher, challenging civilization to reimagine intelligence, purpose, and its place among the stars. And as 3I Atlas drifted onward, leaving trails of evidence and questions alike, the lesson became clear. To observe is to participate, to measure is to interpret, and to witness is to be forever changed. The cosmos had acted, and humanity had been compelled to reflect. The sky was no longer empty. It was a canvas, vast and luminous, awaiting not just eyes, but thought, wonder, and recognition as days and weeks passed. The encounter with 3I Atlas deepened humanity's awareness of its own limitations and aspirations. Scholars began to speak not only of its physical behavior, but of the philosophical space it had opened. This was not a story of alien visitation in the traditional sense. There was no greeting, no signal in binary or language. Instead, the object offered a form of presence, subtle, persistent, and intelligible only through careful observation. Its actions forced a reconsideration of what it means to perceive intelligence, and whether comprehension requires similarity or merely patience and attentiveness. In classrooms, students sketched trajectories and light curves with a new reverence, understanding that equations now carried more than predictive power, they carried dialogue. The motion of Atlas became a pedagogical tool, demonstrating the intersection of mathematics, physics, and the emergent capacity for meaning in motion. Theoretical courses in astrophysics began including modules on information embedded in dynamics, acknowledging that the universe might encode structure in ways previously ignored. What was once thought to be abstract speculation had become a framework for inquiry. Artists responded with immediacy, transforming observation into interpretation. Light shows in urban squares mirrored the green luminescence recorded by Vera Rubin Observatory. Music and digital media incorporated pulses derived from Atlas's rotation and plasma bursts. Poets wrote of the quiet voice of interstellar travelers, of objects that could speak without words, and of the humility required to listen. In every medium, humanity's cultural output shifted to incorporate an awareness that intelligence might not be audible or anthropomorphic, but still profoundly communicative. Societies grappled with a broader existential reflection. If 3I Atlas represented a principle rather than a vessel, an enduring pattern, or an emergent system of behavior, then intelligence could exist in forms fundamentally different from life as known. Philosophers debated whether the act of enduring and acting in space could itself constitute cognition. Ethics and cosmology intertwined. If intelligence need not be biological, then responsibility toward understanding the universe expanded. Humanity's place was no longer centered on human perception alone. It was situated within a spectrum of awareness, stretching beyond immediate sensory experience. Scientists, too, adjusted their perspective. Planetary defense specialists began modeling not just threats, but interactions, recognizing that autonomous objects could exhibit sophisticated navigation and resilience. Exoplanet researchers considered whether other systems might harbor bodies capable of encoding or transmitting information through motion. Each field confronted a humbling lesson that natural laws might allow behavior so subtle, deliberate, and long-lived that it escapes detection without sustained attention and sophisticated instrumentation. 3i Atlas had become a touchstone, a benchmark for the scope and limits of human observation. Amid this reflection, a subtle psychological shift occurred. Humanity began to see itself as part of a continuum rather than a center. The object's precise but non-verbal acts suggested a form of existence indifferent to recognition, yet affecting the observers profoundly. In this way, Atlas mirrored human curiosity, persistence, and creativity. It acted without request, yet demanded reflection. Civilization's aspirations, ingenuity, and collective attention were, for the first time, called into alignment with a phenomenon utterly alien, a silent mentor in motion. The reflective weight of the encounter extended to time itself. Astronomers calculated that it had traveled tens of thousands of years before reaching the solar system, and would continue far beyond humanity's current epoch. To confront such temporal scale was to acknowledge human brevity, but also human capacity, to witness, to measure, and to internalize a story unfolding across millennia. Every observation became a dialogue across time, a testament to patience and comprehension, and a reminder that the cosmos holds lessons that may only be grasped over generations. And so, as telescopes turned and data flowed, as journals published and art responded, humanity realized a profound truth. The encounter with 3i Atlas was not a singular event, but an invitation. It asked not merely what humans could detect, but what they could understand. It demanded reflection on intelligence, endurance, and the invisible threads that connect observation to meaning. The sky had shifted, no longer a distant backdrop, but an arena for engagement, an infinite canvas where the motion of a single object could illuminate the mind, the culture, and the soul of an entire species. The last points of green luminescence faded against the black canvas of interstellar space, leaving only the faintest trace on detectors and in human memory. 3i Atlas, once a subtle speck gliding through the solar system, now receded into the infinite, its trajectory a straight line toward a distant void where stars are rare, and time stretches with indifferent immensity. Yet the absence of its presence was not emptiness. Every telescope, every dataset, every charted pulse remained a testament to a phenomenon that had acted, that had moved with precision, and that had defied understanding. Humanity could no longer regard the sky as inert. It was a field of consequence, where motion itself could bear meaning. Scientists, philosophers, and thinkers across the globe reflected on what had been observed. For the astrophysicist, the data compelled new models of interstellar dynamics, inspiring proposals for missions capable of tracking or even rendezvousing with future visitors. Concepts once relegated to theoretical exercises, autonomous interstellar probes, plasma-based propulsion, or the transport of information through trajectories now demanded serious engineering consideration. Space agencies debated the practicalities of pursuing these phenomena, while academic journals filled with papers attempting to quantify the subtle behaviors that had once seemed inexplicable. Even in the technical rigor, there lingered awe. The universe had acted in a way that human tools could record but not fully interpret. Philosophically, the encounter had expanded the very definition of awareness. If an object without discernible life could act in a manner suggestive of intention, the boundary between intelligence and inertia blurred. Could motion itself, coherent and purposeful over light years, constitute a form of perception? Was agency only a matter of chemical processes, or could it emerge in physical systems across scales and contexts beyond human experience? Every orbit, every pulse, every calibrated adjustment of 3I Atlas became a quiet argument for a cosmos that is alive not in sentience, but in structure, in coherence, and in action. Artists and storytellers continued to interpret the phenomenon. Light sculptures mimicked the faint plasma flares, and compositions attempted to translate its rhythmic pulses into sound. Writers reimagined narratives of contact where dialogue was not spoken but enacted, where presence alone was communicative. Across disciplines, 3-1 Atlas became more than a celestial object, became a symbol of the universe's capacity to surprise, to provoke reflection, and to invite participation in a story far larger than any single observer. The human consciousness itself shifted. Observers felt, in the silent expanse of space, the weight of what had been witnessed. A subtle humility emerged, an acknowledgement that intelligence, persistence, and purpose might exist in forms alien to earthly expectations. Curiosity had been rewarded with insight, but the insight raised deeper questions. What other objects traverse the cosmos, invisible and deliberate, carrying principles or knowledge encoded in motion? Could humanity ever hope to track, understand, or engage with such phenomena fully, or would most remain distant, silent, and enigmatic? The deep space void, once simply a backdrop of stars, now carried resonance. Each glimmer of distant light was framed by memory and understanding, weighted with human consciousness. The cosmos had acted, humans had observed, and the encounter, though fleeting, had left a permanent imprint on thought and imagination. In the final moments, as 3I Atlas drifted beyond reach, there was no conclusion, no tidy resolution, an enduring question, stretching across light years, inviting reflection, study, and awe. It had come, it had moved, it had acted on in its passage. Humanity glimpsed a universe where motion itself may be thinking. The sky remained silent, yet it was alive with consequence, and the questions it posed would follow observers for generations to come, a persistent reminder that in the infinite, curiosity is both compass and companion. Even as 3I Atlas slipped beyond the limits of telescopic resolution, its imprint on human consciousness remained vivid. Each calculation, each plotted trajectory, each faint signal recorded in observatories worldwide had transformed from data into narrative, a chronicle of a visitor whose existence challenged the very definitions of agency and intelligence. For the first time, humanity realized that the cosmos might not be silent simply because it lacked life, but because communication could take forms imperceptible until carefully observed: motion, timing, structure, persistence. The universe spoke, not with words, but with action, and, for a moment, 3I Atlas had ensured its voice was unmistakable. Long after the last visual traces had faded, researchers continued to follow its influence. Proposed interstellar probes now included autonomous guidance systems, capable of detecting and interpreting subtle accelerations and trajectory shifts. Engineers debated propulsion systems that could mimic or respond to phenomena like Atlas's plasma bursts, while astrophysicists revised models of interstellar dynamics to account for precision movement in the absence of obvious forces. The encounter had blurred the line between theoretical possibility and observable reality, opening avenues of exploration that had seemed speculative only months prior. Beyond the scientific sphere, the event provoked a cultural and existential reckoning. Humanity's sense of centrality in the universe, already challenged by centuries of astronomy, was subtly recalibrated. 3I Atlas had traversed tens of light years, enduring the radiation, dust, and gravitational complexities of interstellar space, and had done so in a manner suggesting coherence and persistence. It was a reminder that the cosmos is vast not only in space but in possibility, and that intelligence, if the term could even apply, might manifest in forms utterly alien, yet detectable through careful observation. Philosophers began to explore the ethical and epistemological dimensions of the encounter. If deliberate motion could constitute a kind of awareness, what responsibilities did humans hold toward the cosmos and its objects? Could observation itself be considered an act of participation in a larger system of intelligence? Did detecting agency require interaction, or could understanding exist solely through witnessing? The encounter with Atlas suggested that consciousness need not be anthropocentric to be meaningful, and that the universe might harbor modes of order and communication far subtler than human perception had previously assumed. The aesthetic response was equally profound. Filmmakers, composers, and visual artists drew inspiration from the fleeting green glow and the precise, almost deliberate motions. Exhibitions reconstructed the plasma bursts in immersive environments, translating trajectory data into light and sound. Musicians mapped rotational patterns to rhythm, creating compositions that were both meditative and intellectually provocative. 3I Atlas had left no direct message, yet it had become a muse, demonstrating that the act of movement alone could inspire reflection, creativity, and even a kind of reverence. On a personal level, astronomers and observers reported an ineffable shift in perspective. Nights once spent staring into empty voids now carried a sense of intimacy, as if the cosmos were alive, not in matter alone, but in behavior. Every distant star, every passing comet, every minute fluctuation in light or gravity became a potential interlocutor, each motion a question, a statement, or a prompt to reflect. The infinite had become a dynamic presence, waiting for perception, attention, and interpretation. As humanity looked toward the stars, the story of 3I Atlas remained unresolved in its finality, but complete in its resonance. The object had come, acted, and departed, yet its passage transformed the way humans conceive of intelligence, time, and participation in a universe that is both immense and responsive. Its legacy was not an answer, but an invitation to measure, to watch, to think, and to remain perpetually aware that the cosmos may act subtly, deliberately, and in ways yet unimagined. And so the journey continues, not in the observation of 3I Atlas itself, but in the questions it left behind, questions without end, expanding with every orbit, every distant light, and every mind willing to consider that in the infinite, action itself may be a form of thought. The universe had moved, and humanity would follow its lesson forever, even as 3I Atlas receded beyond the limits of human instrumentation. Its influence persisted, shaping thought and perception across disciplines and continents. The object's journey, though physically brief in the context of cosmic time, became a temporal mirror reflecting the endurance of observation itself. Scholars across fields astronomy, physics, philosophy, and even psychology found themselves reframing questions that had once seemed settled. The encounter forced a reconsideration not only of intelligence and agency, but of the very nature of knowledge. how it is acquired, how it is interpreted, and how humans measure phenomena whose existence stretches across dimensions and timescales that defy immediate comprehension. Astrophysicists returned to the archive data again and again, seeking minute deviations in trajectory, subtle changes in brightness, and patterns in plasma ejection that might hint at principles previously unconsidered. Each analysis uncovered nuances that previous models had overlooked. Researchers noted that the plasma bursts, while brief, were consistently aligned with the object's center of mass, implying an inherent self-stabilization mechanism, while natural explanations like asymmetric outgassing were considered. Simulations consistently demonstrated that the precision exceeded known cometary physics. The object appeared to anticipate gravitational perturbations from planets, asteroids, and the solar wind, adjusting in ways that suggested either an extraordinarily rare natural phenomenon or something more deliberate at the same time. The global scientific community grappled with the implications for future exploration. If objects like 3I Atlas could travel interstellar distances with such coordination and endurance, the search for similar visitors, or even for probes sent intentionally from distant civilizations, became a pressing priority. Interstellar mission concepts, once largely theoretical, began incorporating mechanisms to detect non-radiative signals, slight activations, spin modulation, and directed plasma emissions. Engineers speculated that propulsion methods beyond chemical or ion engines might be feasible if such trajectories could be replicated, drawing inspiration not from human innovation alone, but from phenomena observed in nature, or perhaps from something between nature and design. Beyond scientific circles, the encounter ignited a philosophical transformation. The notion that intelligence might exist as a pattern of action rather than a material entity challenged centuries of anthropocentric assumptions. Philosophers debated whether intentionality required consciousness, or whether purposeful motion, persistent, precise, and coherent over light years, could itself constitute a form of cognition. If an object could act in a manner interpretable as intentional without conventional life, then the universe was not merely a stage on which human life unfolds. It was an arena of interaction where observation and existence intersected in unpredictable and profound ways. Humanity's self-image expanded, not to claim mastery over the cosmos, but to acknowledge its participation in a system capable of subtle communication beyond language or biology. Artists, in turn, embraced the challenge of conveying what could not be spoken or seen directly. Composers created pieces, translating plasma bursts and spin patterns into sound, mapping the pulses into rhythm and melody. Visual artists projected trajectory data onto immersive installations, allowing audiences to perceive motion and precision as aesthetic experience rather than raw data. Writers explored narrative forms in which presence itself was communicative, where the act of moving through space constituted expression. Across Media 3I Atlas became a catalyst for reimagining the boundaries between observation, interpretation, and meaning, demonstrating that communication need not be encoded in words or symbols. It could exist in structure, timing, and sustained coherence. The psychological impact of the encounter was subtle but profound. Astronomers who had observed the object reported a persistent shift in perception. The night sky was no longer inert. Every distant star, every drifting asteroid, every fluctuation in light became a potential actor in a cosmic network. Even phenomena previously dismissed as random were now considered for subtle patterns. As observers pondered the possibility that the universe is structured not only by law, but by action deliberate, observable, yet beyond immediate comprehension, human attention itself became a participant in the cosmic dialogue. highlighting a reciprocal relationship. Observation shapes understanding, and understanding deepens the significance of what is observed. Temporal perspective further enriched the human response. 3I Atlas had traveled tens of light years, existing long before humanity had evolved, and continuing long after any human observer would remain. This enduring presence reframed concepts of time, mortality, and legacy. Whereas human endeavors are ephemeral, often bounded by decades or centuries, Atlas demonstrated that coherence and influence could persist across eons. Guided by force is natural or otherwise beyond immediate perception. In reflecting on this scale, humanity confronted its own brevity, not with despair, but with a sense of wonder that even fleeting observation can touch phenomena whose lifetimes dwarf individual existence, and that understanding, though partial, can bridge temporal chasms. Interdisciplinary discourse flourished. Conferences and symposia integrated astrophysics with philosophy, ethics, and cognitive theory. Discussions examined the potential for life or intelligence to exist in forms unbound by biochemistry, morphology, or familiar perception. Mathematicians explored whether coherent action could encode information across interstellar distances without conventional language, while ethicists debated humanity's responsibilities when encountering systems whose agency could be recognized but not fully understood. Every question raised more questions, and every insight refracted into new lines of inquiry, revealing the depth of mystery embedded in the encounter.